As normal, I love to go back and do a review, especially when we first start a unit, Hayden. I like to keep mentioning the words that we talked about. And we've talked about these words for a while because we've had them on morning work, at least everything but maybe inertia. And we started off with force. And a force, the very simple definition of force is a push or a pull. And those things are going on around us all the time, right? For example, in just a minute, somebody's going to have to come in here and push a mop back and forth across the floor because somebody knocked a big giant cup of water in the floor, right? When the cup was knocked off of the table, there was a force that pulled it towards the ground. What force pulled the cup towards the ground, Veda? Gravity pulled the cup toward the ground. The cup hit the ground. The lid came off. That's equal and opposite reactions. That has to do with Newton's laws, which we'll get into today. And then now there's water in the floor. We'll pause this video. So again, we have forces and motions going on around us at all times, and we probably don't really ever think about it like that, do we? I mean, I don't think anybody thought about gravity pulling the cup towards the ground or using force to push the mop back and forth. We didn't think about that, but it's going on as every day, right? Somebody had to pull the chair out of the way. Judah had to pick a chair up and put it down on the ground so he could sit at a different desk. Forces going on all the time. Those pushes and pulls are constantly happening in our room. Now, that takes me to a second thing. We use this whole thing as a teachable moment because it's super easy to do. If we walk over there right now, the floor is actually a little bit more slippery than it is over here where I am. Why? There is less what, Maddox, on that wet floor than there is over here on the dry floor. But that's causing less what, Hayden? Friction. Friction. Remember yesterday when we rubbed our hands together and we could feel the heat building up on our hands, right? That's friction. Friction is when two things are rubbing together and they're trying to kind of stop each other because friction slows things down. If we are on a wet floor, Hunter, it's a little harder for us to stop because there is less friction. There is still some, but there is less friction over there because friction is that other vocabulary word we talked about yesterday that slows things down. So we'll skip through force there. We answered that question yesterday. Oh my goodness, this thing is slow. Again, we just talked about gravity. I'm not going to sit here and talk about gravity. Thank you, sir. I'm not going to talk about gravity too much because we just talked about it. Gravity is a force that pulls things. Now, gravity on Earth pulls you towards the Earth. Gravity at the sun pulls you towards the sun. Gravity on the moon pulls you towards the moon. Gravity is a force that's pulling. It's very easy, Anna, to get tricked into thinking that gravity is a force that pulls you towards the Earth, and that's it. But you're forgetting that gravity exists in other places as well. So like if you happen to be on Mars, there is gravity there, and it's not Earth's gravity that's affecting you at that point. If you're on the moon, there is gravity affecting you, a lot less than there is here. And we'll get into that as we go along. Just know that gravity is the force that pulls. If you remember, Cameron, on a test, that gravity is what pulls the ball back down towards the Earth, you're probably going to get it right. Just remember, gravity's pulling on you at all times. We talked yesterday about friction. And we'll probably get into today, I think, if it's in my notes, I got to double check those, the video on tribology. Tribology is the study of friction. It's a very cool TED Talk that we'll watch. We'll see about contacting her again this year. I hate to keep bothering her like every single year, but she does seem to enjoy me emailing her and getting on our Flipgrid videos with us. So we'll see about that. It's been a while. So friction, again, when two objects slide against each other, friction kind of makes them stick together. Depending on the two objects, they either don't stick together very well, or they do stick together very well, but that friction between those two objects, that sticking together, is what eventually causes those objects to slow down and stop. Even if you're on ice skates, Brandon, even if you're on ice skates, friction will end up making you slow down and stop eventually. I mean, I watched the Hurricanes play last night, and those guys are skating across the ice at pretty high speeds. Now, sometimes, like, they run into another person and slam them into the wall, right? And then that's what causes them to stop. Sometimes they turn their skates sideways. Ice goes flying. They increase the friction by increasing the surface area that's touching the ice, and it slows them down and stops them, because it's very important to be able to do that. There are some instances, basketball shoes being one of those, hiking shoes being one of those, trail shoes where you want good grip and you want to be able to slow down very, very quickly. right? Nobody wants to have super, super slick things in an instance when you need to slow down. That's why we don't have racing tires on regular cars. They're slick. They're meant for gripping and going fast. They're not meant for stopping very quickly, which is what our tires are designed for. And our tires are also designed to help shed the water and the snow off of the ground as well, which gives us more friction. So let's take a look at this big giant train. And I want you to imagine going outside on the playground. And Amanda, I'm asking you, right? So the train is at the ball field, and I say to Amanda, Amanda, you got to get this train to the front door by the time recess is over. Or you're going to have to walk laps for the rest of the year. And she says, Bullens, that's really not fair. Well, she's about to get real mad because I'm going to tell Max, I need you to move this train to the front door before recess is over, or you have to walk laps. Who's walking the laps that year? Amanda. Why is Amanda walking laps? Akat. She can't move the train, but there's a very specific reason, vocabulary. Why, Anna? The giant train has way more mass than the little train. And we have to figure out what in the world does that mean. Well, if we look at our definitions on our vocabulary sheet, which you all have, mass is the amount of matter in an object. How much stuff is inside of an object is what we're going to consider as mass. So again, as we start to dig into why can't Amanda move the big train to the front door before recess is over versus why Max can move the small toy train, it all has to do with mass. How much matter is inside of an object. Now I want you to imagine, and I may actually have this, I'll see if I can find it while I'm talking about it, a ping pong ball and a golf ball. And let me dig through this here to see if I have that in here. I feel like I do. There's all sorts of stuff in here for science. Well, there's that for certain. I may have taken all of the ping pong balls out for our game. Let me pause this and go grab those. So again, people are passing around the ping pong ball and the golf ball, and they're realizing that the golf ball just happens to have more matter inside of it. So let's get this definition down on here. The amount of matter in an object. I will teach you how to do this with your handwriting later. Not right now, but later. It's very, very, very easy to do. Let me take this. We just listened to you argue on the YouTube recording this afternoon. So, hello, people at home. Kids in my class can't pass around a ping pong ball without being silly. So here are some of the definitions that we have so far. We just wrote mass. Mass is a new definition for all of us. So I see some people with no notebooks out. That's a little scary. You should be writing down the definition of mass, the amount of matter in an object. Now we've covered half of our vocabulary words, actually a little bit more than that if you want to get super technical, as we've moved through this week. So again, just like the ping pong ball and the golf ball, it doesn't always have to be things that are the exact same size. You can have things that are completely different, like the toy train and the real train, and realize that the real train has more mass. And Brandon, something that we start to notice, things with more mass inside of them take more force to move them. Would you agree with that statement? Yes. The more mass something has, the more force it takes to move it. The less mass, the less force it takes to move it. That's really not that hard, and we're already starting to dig into Newton's laws as we talk about those types of things. If I went outside today at recess, and we went to the hill on the playground, you know the hill, right? And I got like this little bitty rock. And I said, Collins, go to the bottom of the hill. I'm going to roll this rock down. And so I rolled the rock down, do you think she would have any issues stopping this tiny little rock from rolling down the hill? No. Probably not. She could probably just stick her foot out, stop it, pick it up, and like throw it back up to me at the top of the hill, because this teeny tiny little rock doesn't have a lot of mass. It doesn't take a lot of effort for me to get it moving. It doesn't take a lot of effort for her to stop it, does it? What if we change things? I have a feeling Reagan's name's still on here. I have to send her this video if it is. It is. I get a huge boulder. I'm talking like huge. And I sit it at the top of the hill. Collins, go down there. I'm going to roll this to you. Do you think she would be able to stop it? No, she would not. And right in the library, right beside Flat Stanley, would be Flat Collins, because the rock would roll right over top of her and on into the woods, right? Do you guys agree with that? Why can't she stop this big rock by sticking her foot out? Jesse? It has too much mass to stop it. Again, if you have more mass, it takes more energy to get you moving, more energy to stop you as well. Inertia. This is not new. We covered this yesterday. It's already on the anchor chart. And if I'm not mistaken, it's already on our note page here as well. Yep, there it is right there. Inertia. Inertia can be broken down a couple of ways, but if we have an object just sitting there, the object is not going to start moving. The object is just happy sitting there. If we have an object that is moving, it really doesn't want to stop moving. It's very happy to continue moving, but forces are always acting on things, aren't they? That object that's sitting there, something comes by and moves it. If it's a kickball, somebody comes by and kicks it. If it's a bowling ball, somebody picks it up. If it's a beach ball, maybe the wind starts blowing and moves it. Once it starts moving, it's typically friction that slows it down and stops it. If it's a beach ball bouncing across the sand, the wind stops blowing, so force stops acting on it. It hits the sand, and that friction between the sand and the beach ball slows it down and stops it. If it's a bowling ball and you roll it across the grass, the friction between the grass and the bowling ball is what stops that from moving. And it's important for us to understand that as we talk about inertia. Objects are happy to chill, or they're happy to keep moving until something changes that. So again, we've already talked about the bowling ball. I'm not going to go over this again because that's what we just talked about. So in my class, I have what we call Newton's cradle. It shows all of Newton's laws, especially inertia and equal and opposite reactions. Once I pull 1 or 2 or 4, whatever you want to do over here, back, they are happy to keep moving until friction acts on them and slows them down. Matter of fact, when they're sitting here, they sat here all summer and never moved. They were happy with that because of inertia. Again, they're happy to keep moving. They're happy to sit still because everything has inertia. And so we're going to take a look at some videos here about some different sizes of this.